Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Welcome to Lady Khadija radiallahu anha online college. Continuing live lessons on A-level maths. This is year 2 pure maths. And today's topic is proving trig identities. And this time we're going to be looking at an example where we're going to need to use the cos A plus B formula from previous lessons. Let's begin. Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. In today's question, we have to prove that the square root of 3 times cos 4 theta, that's the square root of 3 cos 4 theta plus sine 4 theta is identical to 2 times cos, and then in brackets 4 theta minus pi over 6. So just take a look at that and try to see if there's any identities that come to mind to help you try and prove that. And what you're looking for is, firstly, do I start on the left or do I start on the right? When you're looking at the left, try to think, is there anything that you see on the left where you can combine it or manipulate it or change it? And is there anything that you can see? If not, or as well as, take a look at the right hand side. Is it easier to start there? Is there something you can think of that comes to mind that's going to allow you to change what you see there? So most of the examples we've done, we started on the left, but this one, it's actually easier to start with the right hand side, manipulate that, and then end up with what's on the left. So let's take what's on the right and keep it there. That means we'll take everything else and put it away. That's what we're trying to get to in the end. And what we're going to try and work on is the right hand side. So we're looking at this and we see 2 times cos, and then we see in brackets 4 theta minus pi over 6. And what you should think of is your cos A plus B formula, which also has the other version, which is cos A minus B. So that's where you have cos, and then you have 2 angles being added or 2 angles being subtracted. So here, that's exactly what we've got. The 4 theta is our first angle, pi over 6 is our second angle. So let's try and remember the identity. It's cos A cos B plus sine A sine B. If we want to write it in a different way, when we have 2 angles being subtracted within the cos. So let's use that here. The 2 can be put to the outside and everything gets times by 2. So now the cos 4 theta minus pi over 6. So let's take firstly the 2 to the outside, and we're just working on the inside of the brackets here. So you should be quite comfortable with using the identity, the expanded version. So here it's not really called an expanded version, it's just a different way of rewriting cos of 2 angles being subtracted. So what's the different way of writing it? We could write it as cos 4 theta cos pi over 6 plus, and then hopefully you can do the second bit by now. It's going to be sine 4 theta sine pi over 6 and remember that pi over 6 is not an unknown. Pi over 6 is a number, so we can type that straight into a calculator, type in cos pi over 6 and let's see what that gives us. So if you type in cos this bit here, so that's the cos pi over 6. If you want to type that in and see what that gives you, you should find it gives you root 3 over 2, root 3 over 2. So we can replace the cos pi over 6 with something that's much easier to work with, which is root 3 over 2. And it's easier just to put that at the beginning, otherwise somebody could confuse it with the angle, and that's not what we were doing. We were timesing by cos pi over 6, and that's now looking good. Same with the sine pi over 6. If you type that straight into your calculator, that will give you a half. So you can replace that with a half. And then again, easier to put that half towards the beginning. Okay, and looking good. So now just times everything by the 2 that's on the outside. So we can times by 2. So this 2 times is everything on the inside. So 2 gets times by the first term, and then the second term gets times by 2 as well. The first term, well, we've already got a divide by 2 here. So when I bring the 2 in to times by that first term, that's going to cancel. And then this now do the second term, I'm going to times by 2. But again, I've got a divide by 2, so that's going to cancel. So that timesing by 2 was pretty good because it helped us get rid of the divide by 2's. So all we're left with is root 3 times cos 4 theta plus 1 times sine 4 theta, and we don't really need the 1 anymore. Timesing by 1 doesn't make a difference, so we can just leave it like that. Get rid of the brackets since we timesed by 2. And let's compare how that looks to what we wanted it to look like. We wanted it to look like root 3 cos 4 theta plus sine 4 theta, and that's an exact match. So that's the proof done. It was using the cos A minus B identity and then expand by timesing by 2, and that's your answer. Join me again for more in our next lesson. Assalamu alaikum wa rahmatullah. Peace be with you and the mercy and blessing